Hello everybody and welcome. So we've all been there, retrofitting a build, and the owner comes and gives you a completely correct and up-to-date tag list, a Modbus map and a wiring diagram, as well as a well-defined scope of work. In the real world, more often than not, when you're going into another guy or gal's playground, you don't have all the information to hand to get the job done easily. It could be poor record keeping, language barrier, blah 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 blah, but just remember, as a systems engineer, it's always your fault. In our last video, we looked at manually setting the address of this guy. I'll pop a link just up there. In this video, we're going to have a look at how to find the address of a sensor that's already on a network that you don't know. I've changed this, it's a mystery, and we'll work it out from the code. And what we'll also do is write a little program to walk through the entire network and tell us how many sensors we have and at what addresses those sensors are. So let's get to it. Alrighty then. So we are starting off in the same place that we left it in the last video. So we have just this in the main, trying to get temperature and humidity data. Now, as I said in the introduction, I've changed the address to some mystery address. We're still looking at address 10 here. We're not getting any duns coming through, but at the same time, we're not getting any errors and we're not getting any error statuses coming through. We're not getting any actual numbers coming from the sensor. So what's gone on? What's happening here? Well, it turns out we actually are throwing an error and we are throwing up a status code, but because we're looking at an address with nothing there, this error flag is only true for one scan, what it's called. So just one run through the code when it actually executes that command. This view from Tier Portal, it only updates once a second, maybe a couple of times a second. So you'd be very, very lucky to actually catch this and this saying what the error actually is. So first things first, let's have a look at the PLC and see what this actually looks like. So here we are at the PLC. You can see we're only lighting up the transmission light. Now in a very nice feature from Siemens, so the light between these lights can actually leak between the two, so it's not abundantly clear sometimes, but we're only firing out requests. We're not getting anything back on the receive. So this is just firing out once a second just to try and see what's out there. Obviously, we're addressing a place that there is no sensor at that address, so we're just shouting into the void at the moment. But still no error codes coming up on the PLC. So let's try and work out how we get that error code and what we can do with that to help ourselves out. All right, well, we know something's amiss. So what we're going to do is come in here and throw in a new network just under here. And all we're going to do is, when this error goes true for that single scan, we're going to move this, this error code into a new area of memory that we can actually store it. So if we have a look in our Modbus config folder, this error code here that we put in the last video, this is the one that is going to be true for one scan. So this guy here. So I'm going to create a new thing here. It's going to be the same as this, but I'm going to call it persistent error. Is that how you spell persistent? I'm not sure. We'll roll with it. Persistent error code. And that is going to be the same as this guy, so it's going to be a word. And we're going to start it off just as empty. And in this network, we're going to put a little trigger for ourselves. So when error is true, so we can copy that over, we're going to move whatever the error code is into this persistent area in memory. So I can drag that over from there. Easy. So this should tell us what on earth is going on. So let's upload that. Okay, and instantly you can see there has been an error. Still not coming up here at all, but for those singular scans that it is true, we have moved this hexadecimal number here, so 80C8. So that is our error code. If you go into the documentation, this is, it just says, oh, it can't find the address, which is obvious because we've changed the address and we are shouting into the void. But we can use this and the fact that this is a very specific thing to help us build a system that lets us find out where the sensor actually is. So for this, we're going to create our own little function. So imagine that you've got an entire program. When you come onto site, you can come into the program and build this as your own function block and run it and grab all of the data about these sensors. So it's quite a nifty little trick. So make a new block, and it's going to be a function block. I'm going to call it find sensor. And inside of find sensor, basically what we want to do is check if an error has occurred. Well, a very specific error has occurred. So we're going to get this equal thing. So we know from this part here that this, well, we won't do it on the persistent error actually, because that will cause issues. What we're going to do is run it on this, the one that's only true for one scan. You'll see why later. But we're looking for this in that, oh my God, I can't remember the name, database. So what we want to do is say, is the error code exactly equal to the error that we're getting here? So hexadecimal 80C8. So what do we want to do when this is actually true, i.e. we can't find anything at that address? Well, if we're wanting to loop through and find sensors at addresses, we're going to want to increment the address. So let us start with making a Modbus address place in memory. And that is just going to be an integer. And we're going to start that at 1. So now we've got this place in memory that is going to be the address. If we search that address and we can't find anything there, we want to move on to the next address. So we're going to do an increment, blah, 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 maths, increment. And we're going to increment that address. So it's going to go 1 up if it can't find anything there. And at the same time, what we also want to do, because this will have been moved, this error code will have been moved to that persistent place in memory, what we also want to do is reset that. So we're going to move hexadecimal 0, or just 0. And we're going to move that to this persistent error code, just to re-zero it out for the next jump. Just makes it easier for us to see what is going on. So now what we want to do is work out what we want to do when we do find a sensor. So this block here will only happen if we get this specific error, like we search that address and there's nothing at that address. What we want to do now is create another route for when there's no error, and no error is just 0 again. And when there is no error, we want to tell ourselves that we have that we've found something, because if there's no error, it means we are talking to a sensor at the whatever that address currently is. So again, we're going to, let's make a new block for this, new data block, found addresses. And inside of here, I'm just going to create an array. That's the name, sorry. This is going to be an array. And it's going to be an array of integers. And let's, I don't know, make it 5, 6 long just for now. If you know you have like 30 sensors, just make sure that this array is long enough to capture each one of those sensors. So there we go. These are all the addresses that we will find, and this will be the value of those addresses. So when this is true, we actually want to move that information into that array. So this is where we need to address individual arrays. Tell you what I'm going to do just to make life easier. Usually when you're doing like stuff in other programming and you iterate through an array, you just call it I, so you're not having to type out the full names all the time. So that just makes our life a little easier in what is to come. So inside of here, we know if this is true that we have found something at that address. So we want to move the current address to this array. Now, if we just move it into the array, say the first part of this array, we'll write it in this value here, and then when we find the next one, we'll overwrite this, and then when we find the next one, we'll overwrite this. So this will only tell us the last address that we found, and all of this will be blank. So what we need to do is index this array by the index number. So this is I0, 1, 2, 3, 4, 5, so on. And the way we do that is we want to tell it to move to this array. There. So that will overwrite everything, because we're always going to be overwriting the 0th position of this array. So we want to make a variable that is static. I'm going to call it array. I'm going to call this J actually, just because I'm lazy. J is going to be an integer, and it's going to start at 0. Now, because we're starting at 0, that also equals this here. So instead of always sending the most recent found address to the 0th place in that array, we're going to tell it we want it to be variable. So we're going to send it to J. Now, if I just put J in here, that's not going to work, because this is it's a local variable. So we need to do hashtag J. Hashtag in the Siemens language just means it is local and not global. So you can see there, we're going into array I, and this integer J will let us change where we're putting it in that array. So on the first run through, J will be 0, so it will go to this 0th position. So that means as soon as we have found this, as soon as we've found this address and we've moved that information over, we want to increment J. So find increment again, so that the next time we find it, we're going to be going into the array position where J is equal to 1. And then the next time we find one, it's going to go in 2, and so on and so forth. So this is how you manage to spit out a list with everything you've done. Now, obviously, once we've found an address, it doesn't mean that we want to stop, because we want to just keep going and going throughout the entire array. So we're also going to want to increment the actual Modbus address. So we're going to copy that over. And the last thing we want to do, just to be safe, we also want to reset the persistent error code back to 0. So that puts us right back where we were, but we are addressing the next Modbus address, and where we're actually addressing in our list of found sensors is incremented by 1 as well. So just a nice simple couple of things incrementing to help us walk through and find out what is where network wise. And that is that. It's really that easy. So let's upload this to the, oh no, let's not upload it yet. Let's actually include it in the program. So in our main OB, what we're going to do is get our find sensor data block, and we're going to insert it. And what we're also going to do, because we don't want this to just run blindly, we want to tell it when to run. So this could be just sat in your code just on the back end, and then when you get to site, you can plug in and then toggle this code just to run whenever you want, just to do a sweep of everything on the network. So I'm going to make a switch, and not like in previous videos where it's been a physical switch, I'm just going to pop this guy in memory. So I'm going to call this start find. Obviously that doesn't exist, so I'm just going to make it not ideal, but I'm just going to make it a global variable just for ease. So global memory define. So when we come in and flick this make-believe switch, he's going to run this program and iterate through the sensors. So let's upload that and see how this works. All right, and we are running. This part of the code isn't running, so it won't actually do anything yet. But let's set these up to actually see what's going on. So this is going to let us have a look at what's going on in the guts of the operation. Inside of it, do we want to look at this? Yeah, we can have a look at the inside of this and see where our Modbus address is and what it's doing. And in here, this is where we're interested in. This is going to start filling up with the addresses of what we find. Now I've only got 2 things connected to this network, so we're going to find 2, but obviously everything on this network should be able to be found using this. So if we come into the main and flick this make-believe switch by just modifying it to 0, 1 even, boom. Okay, so I've just stopped this. We're getting some really weird numbers here, and I know why. I made a silly little mistake. So basically, this comes back to what we were talking about before with every scan not really updating on this live view. So what I've done is looked at when this is true and when this is not true. So when this is a very particular error and when this isn't a particular error. Now this not being a particular error will just run through for every other scan. What we actually want to do is look at when, if I can come back to the main OB, basically when this is done, when this is successfully completed something, it's not going to throw an error, this is going to be done. So we want to change this guy instead of equaling not an error, which could just be every little scan, which is why these numbers are going crazy. We want to pop in this guy, wherever he is. So the Modbus being done. I can get rid of that guy. Now let's upload this again. It turns out there was another silly mistake. So it was iterating through, but just walking over where the other sensors should be, because I forgot something absolutely fundamental, because we're only here addressing Modbus address 10. So obviously it's always going to be shouting at address 10, nothing's there. So this program didn't work. So what we need to do is, instead of having this address hard coded, we're going to move this Modbus address to there. So cross your fingers and let's get this up and running. All right, so we are running, and now we're actually looking at the first address, Modbus address 1, sorry. None of this is running. This is all live, so we can see what's going on. So you can see our Modbus address is 1. We haven't found any sensors, and this is all not active yet. Good. Right, let's run it and see if it works. So that's good. We can see we're iterating through those addresses. That's address 2, 3. You can see it iterating in the Modbus config file as well. You can see there, we went from 8 straight to 10. So what we've actually done is found the first thing at address 9. So that's popped it in there. It's also iterated over J. So J is now 1. So now we're going to be putting whatever we find next in the next place in this array. And there we go, 17. Now I've only got 2 sensors at the moment, so that's how you do that. This will just go through the entire network and list everything out. Now this is using the set timeout time. So if you're having to go through every address, so that's like 255 possibilities, this would take a good while. You don't need it to spend 1 second doing everything. So I'm just going to stop that running for now. And if we come back to right at the startup, in the previous video, we shifted this into the startup, just doing this com load feature. And the standard timeout here is 1000 milliseconds. So I'm just going to come in here and I'm going to change this to, I don't know, we don't want to go too fast because then you can get a lot of false positives. So we're just going to change this to 100 milliseconds. And we're going to upload all of this. And now when we run this, actually see what's going on. Oh yeah, we need to start it in this menu. We should be going up in address every 1/10 of a second rather than a second. So you can see we're already at address 30 odd. And if we look at the addresses found, we've already found both of the devices on this network, and we'd be at 255 in no time. So there you go. That is how you find all the Modbus sensors on a network if you don't know any of the addresses, just with a couple of loops and a couple of flags, and it gets you this nice little array here of what you've got and where it is. Now obviously this doesn't tell you if it's a temperature sensor, humidity sensor, depth sensor or whatever, but it at least gets you going network wise to know what you've got and where. So thank you very much for watching. Hope this helped, and I will see you in the next video.